Good morning, this is Dr. Turner for Fundamental Mathematics. Today we're going to be looking at 10.1, which is looking at greatest common factor and factoring. If you've done distribution before, this is basically going in the opposite direction or reverse distribution. So hopefully this is something you've covered. If not, it should be a good review. We'll go ahead and get started here. So to start out, GCF stands for greatest common factor. So when you're looking at two or more terms, the greatest common factor is just that. It is the largest factor that is common to both terms. So some people can do this mentally, some people, it takes a little bit, but let's say I have two numbers, let's say 6 and 9, for instance. Now, if I were to list out all the factors of each of these, 6 I can get by doing 1 times 6 or 2 times 3. And 9 I can get by doing 1 times 9 or 3 times 3. You would look at all the factors that are possible, and the largest number that is common to both, in this case 3, would be the greatest common factor. And when you're calculating GCF, it's very common to see it written either uppercase or lowercase, but with a set of parentheses, and then the two numbers you are finding the greatest common factor of inside. So for instance, GCF and then in parentheses 6, 9. If I asked you that question like that, your answer would be 3. So I could write it out notation-wise like this, or I could write it out in a sentence. But it's asking for the same thing, essentially. So a lot of students don't have too hard of a time doing that. If I have, let's say, 12 and 16, for instance, you can break up all the factors. This ends up being 4. And you can write out the factors if you need to. But 4 is the biggest number that goes into both 12 and 16, etc. Now, this is pretty straightforward when we're looking at numbers. A lot of students don't have too big of a problem with that. But then when we get into variables or exponents, that throws people off. Just like integers, variable expressions or exponential expressions can also have factors, and they can therefore have a greatest common factor. So for instance, if I take something like x squared and x to the 4th power, just like we did in number 1, you could write out the ways of multiplying to get x squared. You could have 1 times x squared, or you could have x times x. Next to the 4th power, you could have 1 times x to the 4th power, or x times x cubed, or x squared times x squared. So you're looking at all the common factors, and then you're looking for the greatest common factor, which in this case would be x squared. So just like in number 1, notationally, if I said GCF of, in parentheses, x squared comma x to the 4th power, then that answer would be x squared. You can also combine both integers and variable expressions. So for instance, if I had something like, let's say 7x to the 3rd power and 14x squared. So if you have both an integer and a variable component, then you are looking for first the greatest common factor of the integers, and then the greatest common factor of the exponential terms. So the greatest common factor of 7 and 14 would be 7. 7 goes into both. And then the greatest common factor of x squared and x cubed would be x squared. Okay. So greatest common factor is used when we are factoring an expression. Now, for right now, we're only looking at factoring a common term out of either a binomial or at most a trinomial. So we're looking for the greatest common factor out of 2 or 3 terms. And so GCF is half of your assignment for 10.1, and then the other half would be looking at something like, let's say 8x plus 12. And you would be asked to factor this. Remember that factoring is like reverse distribution. So I'm looking at what can I pull out of both of these. 4 is the greatest common factor of 8 and 12. So I could put that out front, and then what's left is the quotient of each of these terms. So 8x divided by 4 would be 2x, and 12 divided by 4 would be 3. So this is the process of factoring. Dividing out the greatest common factor and leaving what remains inside the parentheses. Again, factoring is reverse distribution. So if I were to distribute that 4 back in, 4 times 2x and 4 times 3, I should get my original answer back. If not, that means I made a mistake somewhere. So be careful with that. Okay. And both in GCF and factoring, this applies to not only binomials or two terms, but it can apply to three terms as well. So for instance, if I have, let's say 6x squared plus 24x plus 18, okay? You're looking for the greatest common factor that goes into all three. So just like we did in number 4, you're first looking at the integers, 6, 24, and 18. That greatest common factor is 6. And then you would divide each of the terms, and what's left is what goes inside the parentheses, like so. That's it for 10.1. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.